Lesson 27B, we are continuing exploring proportional relationships, but this time we are looking at graphs to see if those have proportional relationships or not. And we're still trying to find the constant of proportionality, which is k equals. Anyone need more time to write this down? Okay, so a little bit of background knowledge, same as yesterday. We're still dealing with equivalent ratios. So if they are not the same, when they're reduced, it's not proportional. If they are the same, then that means this is a proportional relationship. So far, so good, right? Go ahead and write this down in your notes again. A proportion is an equality between two ratios. Right, ratios. Proportional relationships, write this down as well. It's a collection of pairs of numbers that form equivalent ratios. And we want to look at a graph to see if it's proportional or not. But before I do that, I need to review with you 5th and 6th grade skills here, because I learned last period that a lot of you forgot how to plot points. So, if you have an ordered pair, it's always in the form of two numbers, number, comma, number, and it's in parentheses, which is what makes it an ordered pair instead of just a list of numbers. So that first number means you're going to the right, and the second number means you go up. And we always start at 0, 0, which is in this corner right there. And we are restricting our graph to just the first quadrant. In 6th grade, you're supposed to talk about quadrants, so this is the first quadrant. So we're always going to the right and then up. So let's say I have 5, 3. That means I go to the right 5, and then from there up 3, which is right there. This would be over 10, up 6. Who can raise their hand and explain to me what 15, 9 looks like? Yeah. Very good. 15 to the right, and then from there, up 9. Alrighty? And then I'm going to give you rulers today so that you can draw a perfectly straight line that goes through the middle of all of those dots. And I do need you to extend your lines all the way to the left and all the way to the right to fill in the entire plane. Okay, don't just connect the dots. It's not kindergarten. You're filling in an entire plane with that line. So yesterday we talked about tables and finding constant of proportionality with a table. So we have x compared to y here. This bamboo, how tall it's growing and number of days. So we listed ratios, y over x, right? Remember this? This is 120 over 2, 180 over 3, and 360 over 6. Those all reduce to 60. Since all the ratios are the same constant number, we have a proportional relationship, and that constant is k equals 60. Meaning that bamboo is growing at 60 centimeters per day. So far, so good? Yes? Okay. So let's say you don't have a table. I still need to know if it's a proportional relationship or not, and I give you a graph instead. That's what today's lesson is on. So this line, this graph, you can tell if it's proportional or not by two easy things. So telling if it's proportional or not with a graph is far easier than table stuff, as long as you follow these two rules. It has to be a straight line, and it has to go through 0, 0, this point. So let me ask you, is this graph a line? It's not a trick question. Is it a line? Yes or no? Yes. Is it going through 0, 0, which is this corner right here? Yes. So that means this graph has a proportional relationship. Pretty easy? Straightforward, right? Alrighty. A linear graph is a graph that is a line. So in the future, from now on, you're not going to hear me say, is this graph a line? You're going to hear me say, is it linear? Okay? Also, with the ordered pair 0, 0, instead of me asking you, does it go through 0, 0, I'm going to now ask you, does it go through the origin? That is what that corner dot is called. Okay, so now looking at number 2 on your notes, I want to know if this graph has a proportional relationship? So you're going to ask yourself those two questions. Is it linear? Yes or no? Yes. It's a straight line. Is it going through the origin? No, it's not, because if you can see closely here, here is the origin. The line doesn't even touch it. It doesn't go anywhere near it. It does not go through it. And since it's not going through the origin, this is not a proportional relationship. It has to be yes for both things. Okay? Turn your notes over. Look at number 3. And think about those two questions again. Answer the questions. Is it linear? And does it go through the origin? I want to know if this is proportional or not. You go ahead and take like 10 seconds and do that. Graphs that have a proportional relationship are always linear and always go through the origin. So yes or no, is it linear? No, it's not. Just because there's a line that's connecting dots doesn't mean it's linear. Linear means it has to be a perfectly straight line. So you see that curve? That means this is not linear. And since it's already a no answer, we know this is not proportional. We don't even have to answer the second question. Don't even bother. It's already no, so it's not proportional. Okay? Questions so far? Okay, look at number 4. We have this table from yesterday. The price of books, however many books. And I want to know if that is a proportional relationship. And we're going to use a graph to check. So on your notes, you have a blank graph, right? I'm going to give you rulers so you can properly and neatly as you can graph this. So you're going to take this table, which is a list of X numbers and a list of Y values, right? You are going to read them like this. This first pair of numbers, X and Y, you read it this way. X, comma, Y. So that one is 1, comma, 4. Then this one, this is 2, comma, 7. And this one is 4, comma, 13. So I'm going to take those ordered pairs and graph them as carefully as I can. So that's over 1, up 4, put my dot. Over 2, up 7, put my dot. Over 4, up 13, put my dot. And then with your ruler, as carefully as you can, draw a line through the middle of those dots. Try not to make it on the edge of your dots. If your line's crooked, it's not going to be accurate. Make sure your line goes all the way through the whole plane. Don't just connect the dots. You're not in kindergarten. We're graphing that line. Now, does your line look like it's going through the origin? Some of you are a little bit sloppy and it kind of looks like it does. So go ahead and look at mine. Mine is digital, so it's perfect. Does it go through the origin? It does not. So if you look really close, here's the origin. My line is not touching it, right? It's touching over here at, this is the number 2. Or it looks like it's touching at the number 2. So, it doesn't go through the origin, so it's not a proportional relationship. Okay? Now, like I said, it's really hard to tell with a pencil line because you might have drawn it crooked. Maybe your pencil's really fat and it just looks like it's going through. So you could also check the ratios, which I wrote on your notes. And this is important. If you can't tell, you're not positive that this is going through or not, you don't want to get it wrong, right? You need to check the ratios then, which is what we learned yesterday. Y over X. 4 over 1, 7 over 2, which reduces to what? 3.5. And then 13 over 4, which is 3 1/4. Are those ratios the same at all? Those are all totally different, right? So this is obvious now that we proved this graph is not proportional. Your line might look like it is, but this is proof that it's not. So if it's hard to tell, do the ratios. Got it? Go ahead and write those ratios down. And please do number 5 exactly how we did number 4. Plot those points, draw your line as perfectly as you can. And if you can't tell, please list the ratios. Go ahead and list the ratios anyway, actually, for number 5. We're comparing cups of red paint to cups of blue paint, and I want to know if that is a proportional relationship. Red is X, cups of blue is Y. You have our graph. 3, 2, 12, 8. 15, 10, meaning go over 15 up 10, and then carefully draw your line. Does it go through? Is it straight? Is it proportional? Yep. This is a proportional relationship. I also asked you to list the ratios, so please do that if you still haven't. Y over X, so that's 2 over 3. 8 over 12, which is 2 over 3. 10 over 15, which is 2 over 3. Are they all exactly the same?
Yes.
So what does K equal here? 2 over 3. Yeah, ratios are all the same, so that's our constant. And if the ratios are all equivalent, we have our proportional relationship. Ratios are equivalent. Go ahead and start number 6 the same way as well. Hours worked is X, yards of dirt excavated is Y. List those ordered pairs, just to be clear. 1, 4, 2, 8, 3, 12, 5, 20. Okay, here are my points. Here is my line. Does it go through the origin? Looks like it does. Is it a straight line? Yep, it's linear, goes through the origin, so this is a proportional relationship. I'm going to check my ratios anyway. And I get 4, 4, 4, and 4, yep. And I asked for what is the constant of proportionality? And I see most of you did ratios, right? You did this. And what is the constant? K equals 4. Now there is a way to find that constant without doing ratios and just looking at the graph. Here's how. Right here, this point is really important because it is at the ordered pair 1, something. And it is at 1, K, which is in this case 1, 4. Alright? I'm going to talk a little bit more about that. This one was the dirt's being excavated at 4 yards per hour. Fill in the blanks for this sentence, please. If all ratios from a table are simplified and equivalent, that ratio is a unit rate, or the constant of proportionality, and we already knew this, right? So on the graph, like I was just telling you, you can also find the constant of proportionality without using ratios. You can just look at the graph and find it. And it is at 1, whatever number that is at. And that doesn't mean that it's at the first dot. It doesn't mean it's at the first number. It means that it's at the number 1 on the grid. So this is at 1, K. K meaning constant of proportionality. So whatever number is at the number 1. Again, not the first dot, not the first table value, the one at the number 1. Go over from 0, over 1, and up until you hit the line. And K is what we're using for constant. So let's look at this graph that we just finished. This is the one you just graphed. Over 1, up until you hit the line. There happens to be a dot there for this one. It's at 1, 4. And this 4 is our K. Okay? If it's on a table, you can also tell if you have an X value of 1, the Y happens to be your K. But there isn't always a 1 in your table. But if there is, you can also easily see it in your table. Okay? look at number 7. Go ahead and do what we've been doing. Plot those points, graph it, see if it's proportional, and then tell me what K equals. This is comparing the price of numbers of pens. Here's my empty graph. I'm going to plot my ordered pairs, which is 2, 5, 4, 10, and 5, 12 and a half. 12 and a half is between 12 and 13, so that would be the space between those lines. Notice my dot is in the space between the lines, and then draw your super straight line, and it should go through the origin. This is a proportional relationship, and I want to know what K is, which is right here. Is there a dot there? There's no dot there, right? But over 1 up until I hit the line is right there. It's really hard to tell what it is, which means in this case we need to use our ratios. Okay, it's easy to find what K is if it happens to go through a dot, but this one doesn't, so you have to use ratios. 5 over 2, 10 over 4, which is 5 over 2, and then the last one is 2.5. Let's make them all decimal so that we can tell. This is also 2.5 and 2.5. Are they all the same? What is K? 2.5. Ratios are equivalent, 2.5. So again, your graph is really hard to tell what K is. Not only because you used a pencil to draw it, it might not be perfect, but also because it doesn't perfectly go through one of the crosshairs on the grid, right? And there is no dot there. So in that case, you do have to use ratios. So 2.5, that is in money $2.50 per pen. Remember, our constant is also the unit rate. Yes? Okay, so like I said, sometimes it's easier to use a table to find K. Sometimes it's easier from the graph to find K. You can do both of them to be extra sure. So let's do a little bit of practice finding K on a graph. That first one at the top of your paper, I want to know what K is. So go over 1 up until you hit the line. Over 1 up until you hit this slanted graph line. Here's 1. I'm going to go up until I hit it. There happens to be a dot there. What is that dot at? 6. So my ordered pair is 1, 6. My K is not 1, 6. It's just this number. And what number is that? 6. So 1, 6 tells me that K equals 6. Make sense? Good. That is because this is a perfect graph. There happens to be a dot there. It goes through the crosshairs. It's really easy to read this one. We're like, oh yeah, it's at 6. But look at the second graph, the bottom one. Is there a dot there this time? Here's 1. I'm going to go up until I hit my dot, my line, which is right there. There is not currently a dot there, but that is still K. You just have to read it this time. What do you think that number is? Right, it's at 1, 3. There is no dot there, but you have to read it pretending there is a dot there.